All right, hello once again. This is Jeff Scott coming at you with JavaScript, courtesy of Murox, JavaScript 2nd edition. We're up to Chapter 11 of 17, which is called How to Create and Use Objects. Now we have talked about some object data types in earlier chapters. We've talked about the string object type, the array object type, the date object type, and maybe a few more. But now in this chapter, the idea is that we should learn to create objects, our own objects, and our own object types. All right. And one of the things that gets discussed in here also is they keep looking at and beating kind of almost death this Task Manager app. So our objectives: create objects that have properties and methods by using object literals, constructor functions, or the create method of the object. Use the properties and methods of objects that we ourselves create. Add methods to the prototype of native object types such as strings, dates, and math. Create factory functions that return objects. Describe the inheritance hierarchy for object data types such as object, string, number, boolean, date, array, and function. Describe the differences between creating objects with object literals, with constructors, and with the object.create method. Explain how two variables can refer to the same object. Describe the use of factory functions. Describe the use of prototype objects in terms of inheriting and overriding the methods of an object. Explain how to create and use cascading methods. Describe how to use the delete, in, instance of, and type of operators when working with objects. Now, a couple things as we get started. To me, in some ways at least, Chapter 11 kind of provides a breaking point, so to speak, of what we've been talking about. Because to me, every single chapter from here on out is complex. And the reason I'm telling you that is ideally you've all looked at and you've been reading every chapter in the book along the way. All right, you have to understand the earlier stuff to understand this stuff, but it gets harder from here on out. So you'll have to read the chapter. In some cases, you'll have to read the chapter multiple times. So they show here the fact that JavaScript has a flat hierarchy of native objects. At the top level is the object type. So basically everything is of type object. Underneath that, at the next level, are what you see here: string, number, boolean, date, array, and functions. What this hierarchy means is that all of the object types are at the second level and they all inherit everything directly from the object data type. Now we're going to see examples on how to create these in just a second. But again, JavaScript provides a two-level hierarchy of object types. The object is at the top and what you see down below it is in the next level. So all the objects at this second level, and really this is level 0 and level 1, so all these level 1s, they inherit directly from object. When you create a variable with a literal value, JavaScript converts it to its corresponding native object type. It's a best practice to create native objects this way rather than use the new keyword. To access a property or a method, you use the dot operator or you use brackets. So they're starting to show you some ways that this is going to be done in here. For instance, how to create a new object of the date type. And there's other examples in here also. So notice you could say var last name equal hopper, or you could say var last name equals new string hopper. Either one of these would work. Now most of the time you don't do it this way when you don't have to, because it's just more work. All right. Again, there are two ways that you can use properties and methods of native object types. So in other words, this right here that says length equals last name dot length is the same thing as saying length equals last name, and then in brackets, double quote length, double quote, or it could be single quote too. All right. Again, most people tend to use the dot syntax because they find it easier, but it's not mandatory that you do that. All right. So let's talk about how to create your own objects. The simplest way to create your own object is by storing the object literal to a variable. And you'll notice that in this case, because this is a great example, you use curly braces. We looked at the brackets when we were talking about how to do this. We should do this for an array, but this isn't an array. So you declare a variable that's equal to a pair of braces. Then within those braces, you can code properties and methods for the object, as you see in the example. I have to stop for a minute. Sorry about that. Again, that's the problems that I run into when I tape at home. So, when you create an object with a literal value, it's known as an object literal. So you can add properties by coding pairs of property names and values separated by colons. All right, so we've got an invoice. It's got a property. It's got a name of tax rate and a value of 0.0875. When a property name is paired with a function, it's called a method. Now, you may or may not understand that, so let's just try to put it into a little bit more perspective. Again, this chapter is entitled How to Create and Use Objects. All right? And the key thing when you're working with this is to realize you're working with object orientation. So what a method is it's a function that's written for an object. All right? Inside of the method, the value of the this keyword usually is the object itself. And you can also nest one object inside of another object. Again, the idea behind this presentation is to give you, all right, is to give you an introduction to this. So in this example that we saw here with the tax rate, an object named invoice is initialized with one property named tax rate with a value again of 0.0875. In this next example, the invoice is initialized with one method named getTotal. In the next example here, the invoice is initialized with a property and with two methods. So after you create properties and methods for an object, you can use them just like you'd use properties and methods of any object, like the number or any other objects. So you can again use either the dot operator or the brackets to refer to the properties and methods. All right. How to add properties to an object? Well, the idea behind this is sometimes after an object is created, you might discover that you weren't complete with what you put into it. In other words, once an object is created, you might want to add new properties and or new methods to it. All right. You can also change the value of an existing property by assigning it a new value. You can also use the delete operator, as you can see right here, to delete a property or a method from an object. Now remember, one thing about working with objects is that an object does not hold, the variable for an object does not hold the actual object itself. It holds a reference to it. So when you pass an object to a function as an argument, you're passing a reference. All right, we've talked about that a little bit in the last chapter. Now, when you look at this right now, it's very important that you understand this. All right, when we do this, when you say var today equal new date, like this, that creates this. In other words, today is, sometimes it's even called a pointer, but it references the date object. So when you assign today to now, what that does is that creates an alias. So today and now both point to the same date object. All right, when you use JavaScript, again, you can create your own object types. Also, when you do that, you can use what are called constructor functions. Sometimes they're just called constructors. This lets you create multiple instances of the same object. So let's take a look at the examples that are in here. So notice here we're creating some new instances of an object type. So we're creating a new invoice that's called invoice 1, and you can see what we're passing to it. We're creating another new invoice of invoice 2, and you can see what we're passing to it. All right. Once you do that, you're able to go in and start immediately using the methods and the properties for the object that you've created. Now, this gets a little bit confusing because sometimes what ends up happening is after you've created the object and you've been looking at the properties and the methods, you might decide that you need to add a new property or a new method. All right? And to do that, you want to use what's called the prototype object of an object type. And we're going to get into prototypes in a minute, but it's very important that you do it that way. All right? So in fact, let's just do that now. Let's start talking about prototypes. So what is a prototype? Most programming languages use classes to create objects. A class is also known as a blueprint. It's a description of the object that the class will actually create. Typically, this is known as a class, this kind of language is a class-based type of language. Now, JavaScript doesn't work that way. JavaScript uses what's called prototype objects that are cloned when you create new objects. So, whereas one that uses classes is called class-based, JavaScript is actually called classless or prototypal. Prototypal? I'm not sure. I think it's typal. When you create a new object with an object literal, it's cloned from an object named object.prototype. When you add a property to an existing object, it's created directly on the object, not on the prototype. So you can override properties on an object's prototype by coding a property of the same name directly on the object. All right? Again, clear as mud, I'm sure. There are going to be some examples that are shown right here. You'll notice the toString returns a string that represents the object. Value of returns the primitive value of the object. And has own property returns a Boolean value indicating whether the specified property is defined directly on the object rather than on the prototype. So here's some examples of calling and overriding the methods of an object's prototype. Again, the only way that this will make sense is once you start looking at it and working with it. And even then, I'm just, for lack of better words, I'm warning you, it'll take some time because this is not easy stuff. So you might think, okay, why not just create object literals with properties and methods? Okay, so they give an example here. They start giving an example right here. They say, imagine that you have an invoice data, all of your invoice data in an array, as in the example that's shown here. So imagine you want to loop through the array, load each nested array that's in there into an object. So we've got several arrays inside of an array. And we want to get total method that's going to add everything together. Okay? Well, it can get really tricky and very complex very fast. So in the second example that's in here, shows how you could do it with an object literal. For each nested array. If you did it that way, you would create a new get total function for each loop iteration. So if you had 1,000,000 invoices, you'd have 1,000,000 of these functions. Well, that's not what you'd want to do, so that's not really a great example either. Put this another way, it makes sense for those to be each object's own properties. Think about it this way. If this confuses you, think about it this way. Imagine that what was in here, in each one of these, come on. Oh, I lost my place. All right, so imagine what was in here was, called data find, but imagine this was information about each person in the class. So let's say we've got Bob Smith. Bob is a male, and his height is 72 inches, and his weight is 200 pounds. Then we've got Mary Jones. Her height is 60 inches, and her weight is 110 pounds. All right, so what we're talking about in here is we could take each object and have it hold its own stuff. All right, why? Because typically you're going to need multiple instances of an object. All right, so what you want to do is you'll want to put the methods for the object on its prototype. Okay? And again, that's what they're starting to show in here right now. So if you're going to create multiple instances of an object that has methods, you should create the methods on the object's prototype and not directly on the object. It saves memory, since each instance of an object refers to the prototype method rather than duplicating its own, as we just talked about. And if you do want to add methods to the object's prototype, you can use the constructors or the create method that we're going to talk about in just a minute. So again, if this does not make a whole heck of a lot of sense to you, I would highly recommend that you go back and read this many, many times. So constructor functions in JavaScript let you create an object type and customize its prototype. But remember, JavaScript is not a classic or class language. So constructor functions don't always behave the way programmers with a classical background expect them to behave. So in ECMA script 5, they added a create method to the object. This method lets you directly specify what object to use as an object's prototype. What this means is you can create a prototype object that contains the methods you need, then pass them to the custom prototype object. You pass this object to the create method, and they will actually show you right there, that create method, creates a new object. The first parameter that gets passed in there is the prototype used to create the object. The second parameter is optional, and it sets the object's properties. Again, there'll be more on this as we go on in the book. So the create method lets you specify an object's prototype. Then you can use some of the stuff we talked about earlier to add properties to the object returned by the method. In particular, you should add any properties to that the prototype expects. All right. Now, factory functions are something that can be used to create custom prototype objects. They're similar to constructor functions, but they don't require the use of the new keyword. Okay? And again, this will only start making sense when you start working with it. The idea is start small and continue to work your way up from it. So this next task manager example that you see in here, this next example is going to be another version of the task manager example. The big difference, though, is in this version, it uses objects instead of functions. And it should talk about much of the stuff that we've already talked about. All right, so you'll notice as we start looking through this, we again, up in our head section here, are adding our library functions. This application is going to convert the storage and the task list libraries from function libraries to object libraries. It's also going to add a task library for working with individual tasks. So there's the HTML. Here's the library underscore storage.js file. It starts by creating an object that's named storage prototype, which is used as a prototype to be able to create another object. The prototype object creates a get, a set, and a clear. The get retrieves a string from local storage, converts it to an array, one task for each element, and returns the array. The set accepts the array, converts it to a string, and stores it in local storage. The clear sets the string in local storage to an empty string. What's also shown here in the book on page 337 and on this next slide here is the task library for working with individual tasks. It contains a constructor named task, which accepts a parameter named task. Within the constructor, a property named text is created and assigned to the value of the task parameter. After the constructor function, the code adds two methods to the prototype object. All right. Again, you could have built the storage and the task libraries with either factory functions or constructor functions. Which you choose is a matter of preference. All right. Again, there'll be more in a later chapter that's in the book. On 338 and 339, they show the library for working with the task list. It contains an object named task list that holds, edits, and displays different tasks. Because only one instance of the object is needed, it's coded as an object literal that has 4 properties and 7 methods. All right. So in other words, this entire thing is made up of, this is the object. This is the task list object, for lack of better words. So first we have a tasks property that contains an array that holds all the tasks in the task list. Then there's a load method, which checks whether the task array has any elements in it If it doesn't have any elements in it, it calls the get method of the storage object to retrieve the tasks from local storage. It also has a save method that calls the set method of the storage object to store the tasks in the array in local storage. Then there's a sort method to sort the array, an add method to add or accept an instance of a task. In other words, you're about to add a new task. There's a delete method to delete a task, the clear method, which empties the array, and there's a display method. The display method starts by calling the sort method, and then it loops through and it holds this as basically a big string. So the task property contains an array for task objects, and the storage property contains an object returned by the getStorage function. The values of this display div and delete click handler will be set by the code in the main JavaScript file. So in other words, we're now looking at yet another way of doing it. And this other way of doing it right here, we'll be doing it literally utilizing objects. Okay? So here is the main JavaScript file starting on page 340 and showing it on 341. So the JavaScript code for this is going to create 3 different event handlers. All of them are going to call the methods that we just looked at previously. The onload event handler attaches the event handlers. The first 2 functions are attached to click events for the add task button and the clear task button. The delete from task list function is passed to the task list object in its delete click handler property. This is the function that's attached to the click events for those delete hyperlinks that you saw for each of the tasks. The display method also needs the div element for the tasks, and that's passed to the object in the display div property. The last 3 elements, or 3 statements, in the onload event handler call the load and display the methods for the task list object. So again, we're working through this, and we're working through it utilizing objects. All right, starting on 342, and let's see how long this goes. Oh, I guess for about 10 pages or so. They give you some advanced skills for working with objects. It says, although you won't use these skills in every app, you should at least be aware of them. When you create objects, you can inherit methods from other objects. This lets you create a base object with common methods and then extend them to more specialized methods. If that doesn't make sense, think about it this way. Let's suppose that I create let's say that I work for a bank, and I've been told we're creating a new application for the bank. It's going to be object-oriented and in JavaScript and boom, 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 boom. So I decide I'm going to create an object that's called a bank account object, because everybody who comes in for a bank account, regardless of the type of account, they need to give their name, their address, city, state, zip, all their goodies. So I create basically this bank account object. And the idea is I'm never going to really create one of those objects because it's too general. It's like saying to somebody, I bought a dog. And they'll be like, well, what kind of dog? Well, I bought a golden retriever. Oh yeah, male or female, etc., etc. I'm getting more and more specific as we go on. Well, in the same way, I can create a very general type of class, and then I can have other classes inherit from that one. So what they start to show here is this percent prototype. It contains a single method called getPercent. All right. And what we can do then is we can create that and then set it up so that other objects are able to work with it. So inheritance allows you to share basic functionality among several objects. When you override a method on a prototype object, the new method replaces the old one. So they'll give you some examples in here that are going to work with this. To inherit the methods of an object created by a constructor, you set the prototype object of the child object to the instance of the parent object. Now I'm amazed I was able to read that and not make a mistake. But again, the idea is you have to read this and reread this and reread this for it to start making sense. You can also add methods to native object types. Remember, at the beginning of the chapter, the very beginning of this chapter, we talked about the fact that when you work with this, that there is an object data type, and then underneath object there's string, number, boolean, date, array, and function. So you can go and add a method to a native object type. And to do that, you add a new method to its prototype object. You can use the this keyword if or as necessary. It's a good practice to see whether or not a method that's similar to the one that you want exists before adding it to the native object, in case there's a method with the same name, or just so you don't have to duplicate the work. You can also create, if you look on pages 348 and 349, something that's called a cascading method. Again, as I mentioned to you, this is going to probably be up there with about as complex as it gets. When you've got a cascading method, a cascading method is a method of an object that can be chained with other methods. So this dot this type of an idea. And if we take a look, let's see, I think there's an example in here someplace. This dot add, etc. Here's a better example. My car dot drive 20,000 miles dot change oil dot drive 4,000. All right. So again, a cascading method is a method of an object that can be chained with other methods. It's also called fluent because of the way that it reads. A method must return the object represented by the this keyword if it's going to be chained to something else. All right, a few more operators on pages 350 and 351. The in, instance of, and type of operator. The in, and you can see it right here, the in operator returns true if an object has a named property. The instance of returns true if an object is an instance of the specified object type. That includes the object type of the object as well as its inherited type. Then finally, the type of operator lets you determine the type of a variable. So in other words, it will evaluate to number or to string or to boolean if it's primitive, and to object if it is an object, and to function if it's a function. And if it doesn't know which of those it is, typically it'll just default then to undefined. So the last part of the chapter, what is done starting on page 352 and going on for the next 6 or so pages, is the last part of the chapter uses some of the advanced skills to further enhance the Task Manager app. So the native objects library adds a capitalized method to the native string object. The storage library file has been enhanced to separate the functionality that gets strings in and out of local storage. And the getStorage factory function accepts a key value and uses the create method to create a new object of the string array storage prototype object. So in other words, what we're trying to do, depending on your point of view, is we're trying to take what we're working with and either make it harder for you or make it simpler for you to use, although it may appear more complex when you take a look at it. So the properties that are in here, I think they're, I don't know if they're shown in here or not, I guess some of them are. They're the same as for the earlier figure, and the methods have the same functionality. What's different though is that all of the functions now return the this keyword, which makes them cascading methods, which means that you can now chain them. So what you see here is the enhanced main JavaScript file here. In fact, I think that's So again, it's pretty much set up the same way it was earlier, except now you can chain methods together. And if you look at what's shown there in the yellow, you can see an example of chaining methods. Now the author mentions on page 358, now that you finish the chapter, you should be able to develop applications built around your own objects, methods, and properties. The key thing though is when you work with this is start small and work your way up. There is really and truly a lot more involved in doing this than most people think. All right? So we'll come back in a couple minutes, and when we do, we will be into the last chapter of section 2 in the book, which is chapter 12, and chapter 12 is on how to use regular expressions, how to handle exceptions, and how to validate data. All right? All very important topics, which we'll come back to and talk about soon.